Good morning, scientists. This is Mr. Overholt with the Winston-Salem Forsyth County School Science Department. Let's go ahead and take a look at our observation for the day. Not a cloud in the sky, the sun is out. It is a beautiful day. Kind of like what we saw yesterday with our map and data. Clear out and be beautiful today. I think we're going to get exactly that. Let's go to the data. And then our weather data from Warm Magnet Elementary School in the heart of Winston-Salem Forsyth County Schools. Currently, we are at 52 degrees Fahrenheit. Our winds are non-existent right now. Let's check out the winds when we get to the windy map today. It is very calm outside, as we saw from our observation at the back door. We don't have any rain today. Yesterday, we ended up getting right around a half an inch of rain, just a little bit over a half an inch. 0.57 is what the rain gauge read at more yesterday. Today, our barometer is sitting at 29 and 76 hundredths inches of mercury and says that it is steady, which means that it is sitting right about that spot. We are not rising lately. We are not dropping. We're just kind of going to hang out right there for the near future. I do believe that we're going to drop with a little bit of this cold front that's going to be coming through later on. So let's go ahead and check out our observation, our data, and do a little bit of comparison here. Um, temperature's all right about the same. Our pressure is 200, about 2/10 of an inch of mercury higher than we have been. We did have a shot of wind from the north, I noticed earlier. And we're not having any precipitation right now. It is beautiful out. It's clear, sunny, and cool. All right, so let's go ahead and look at the weather map and see what we notice. There's a couple of things that I wanted to talk about today. First, we've got this area of high pressure that's right here, which is causing us to have our clearer skies today. It is not, notice that we're about equal distance between here and where we are, the H and where we are, and the L. That's a little bit further away at the L, but so that's why our numbers do not say we're at high pressure. We're not say we're at low pressure. Our numbers are kind of in the middle there. So, with that being said, it's kind of surprising that we are as clear as we are. I have a hunch because of this green spot right here that probably is going to move into our area and give us a little bit of clouds later on. Coming across the mountains usually loses some of that rain as we come over. They call that the rain shadow. As it comes over towards Winston-Salem, we're still within the shadow of the mountains, and which means that we don't get all the precipitation that comes across. So we've talked a lot about the blue line as a cold front and the air masses that behind it. We've talked about the warm fronts before and the fact that we've got warm air behind it. Now, if you notice right here, I've got a purple line and it's got triangles and semicircles that are going. So it's got the symbol of a cold front, it's the symbol of a warm front. They're all pointing in the same direction. Um, Red and blue make purple, which is why we have what we have. And that is called an occluded front. An occluded front. Occluded fronts are when warm air is in one location and cold air mass, a cold front comes into the same spot and catches up with it. Usually there's cold air in front of the warm air as well. So we've got cold air, we've got warm air, and we've got cold air. So as they come together, we see this purple line, which calls it an occluded front. So let's talk a little bit about the water cycle. What speeds up evaporation? What gives more evaporation, which would cause more moisture to be in the air? Warm air or warm air heat causes more evaporation. So the more heat we have, and the more opportunity to have moisture in the air. So my warm front is bringing with it some moisture. Now, what happens to make clouds? Go back to the water cycle. Yeah, we're looking at the cold air condensing it. So I've got the cold air cooling it down and condensing it. So once I have moisture in the air, the condensing it, and this right here is condensing it and it's cooling it down enough. So it's actually changing state of matter. It's a liquid here, is what the green is. But as I get up here into this blue spot, that's in the snow range. So it's getting snow up here. That's how cold it is in this area because of this cold front. This is up in Canada, so that's part of the reason why it is. It's a long ways from the equator. So we look at this and we say, okay, so we've got more storms that are there because I've got warm, moist air being cooled down by cold air on this side and cold air on this side, and it kind of squeezes out the warm air. And it pushes that warm, moist air up into the atmosphere. We also know that when we get up in the atmosphere, it causes our temperatures to cool. Think about the pictures you see of mountains with snow on the top. The higher you get in the atmosphere, the colder it gets. So if I have cold air on two sides of my warm air squeezing it and it pushes, we know that warm air rises. So warm air is going to rise over top of that. When it rises up higher in the atmosphere, it's going to condense and have a better chance of having some storms in there. So that's what the occluded front is. So we see an occluded front, that purple line, that's what that means. But we oftentimes will see a blue line and a red line coming together. We have another example of it over here in the Pacific Ocean. The blue and the red have come together and made that purple up there. So that's kind of what we're looking at. Let's go to the windy map here. I don't want to take too much of our time, but I want to make sure we see where this is happening. That's happening right up through here. Um, and we start to see. So you see, we've got the cold air. We've got this V shape in here, and that's where that the warm front would be coming right off through here, and then the occluded is up in there. And there's our other cold front, and this is where because Michigan's getting some cold weather. They got some snow just a day or so ago. I've got some family right about there, up in the tip of the mitten. Everybody sees that there. That's there. One more thing I wanted to make a comment about is as we look at precipitation, um, we know that we've got to have moisture so that we don't have the Gulf of Mexico. We don't have an ocean here. But each of these things that we see right here, these are what's called the Great Lakes. The Great Lakes, there's 5 of them. So we've got Lake Huron and Lake Ontario, Lake Michigan, Lake Superior, and Lake Erie. Together, the HOMES. They call it HOMES, is how the acronym goes to remember them. So that's where you have all this moisture that gives us the opportunity to get all this right here. They're getting the moisture off of these lakes, and that's what's causing these storms. So that's why we don't see a lot of rain over in here because we don't have a lot of moisture coming into that area because this is all plains, this is all mountains. And there's not a spot of water out there to have that water cycle happen. So that's where you get some storms over in this area, upstate New York, the Rochester, Buffalo, an area. They always get lots of snow in the wintertime. It's because they're picking up moisture coming off these Great Lakes, and it dumps it right about here. So want to make sure we're seeing some of this. Let's look a little bit at our pressures for the day. Um, this is our button for that. So here's our pressure. We're sitting at the R on near 29.8 inches of mercury. That's about right. As we march through the day, we're going to see how this changes. Um, we drop down a little bit. We are going to see a few clouds this afternoon, I think, cut because of that. Those clouds coming across the mountains. Not a whole lot, but we notice this is that part of the pressure coming off that cold front that we have, and it kind of is just moving off to the east, and that's what we're kind of watching here. But today's going to be a pretty good day as we see it coming through. We talked yesterday about seeing a storm kick up over here in Texas that comes across for later in the week. So let's throw the rain and thunder on here. And let's see if there's any stump. So there it is. That's the moisture that as we come into Thursday, I believe is what we said. It starts to look a little bit more on the nasty side. All those little squiggly lines in there, those are lightning. These little snowflakes you can see up in here. So it gives us a little bit more information there. And the pink stuff is where it is the heaviest of rain that we see. So that's in that area. So we're going to keep our eye open on that one. I don't think we're going to see anything more than thunderstorm out of it if we see that at all. So have a great day, ladies and gentlemen. Keep looking to the sky, look at the clouds. Do some journaling as to what you see in the sky. Um, what do you think is happening up in the atmosphere as you see clouds start to come in? What's happening with the water cycle? What part of the water cycle causes that cloud to appear? Causes the cloud to get bigger and darker? Those are the kinds of things I want you thinking about, making sense of as you are doing your observations of the sky and the data around the weather around us. Thank you so much for listening. Have a great day. And don't forget, we do science well.